Good afternoon to everybody, and thank you to Amici della Terra and to EDF for the invitation to the European Space Agency and to myself to intervene on the topic of the support of space to the environmental change activities. I'd like to ask Tatiana, who's remotely helping me on the slides, to display the presentation. So basically what I'd like to give you today, it's a very short overview of the European Space Agency's contribution to climate change, science mitigation, and of course, Earth observation. And here we have, next slide, please. We have the overview of what ESA does. We are an agency, a research and development agency, of course. We've been working over 50 years, as it was just said, in the field of space science, but also in the field of application and in the field of remote sensing in particular, developing satellites to support environmental activities and climate change actions. We have a budget of about 6 billion euros, and we work very closely in partnership at European level with the European Commission. We'll hear from Mauro Facchini what the Commission does with us, and we just heard from Mr. Pignataro, and also with EUMETSAT, of course. We have about 5,500 people working for ESA, both staff and contractors, who actually support the activities over a number of different centers. And our headquarters is in Paris, but the Center for Earth Observation is actually located in Italy, near Frascati in Rome. Next slide, please. So what we do is we take the pulse of our planet, in the sense that we do have satellites rotating around the Earth about 800 kilometers from the Earth. These are called remote sensing satellites, and those satellites give us a different perspective and different overview over the Earth, over the status of the Earth, but also over a long term of time, so over a long period, because we collect data since over 30 years through ESA missions. We started to launch the first mission in 1991. It was called the ERS-1, and since 30 years we've been collecting data which are coming from satellites of a different nature, rather optical satellites. And so here you see a little bit what we mean by taking the pulse of our planet. We do look at different aspects related to the state of our planet, and it's like a doctor measuring every day the situation and the environmental parameters related to our Earth. And these parameters are the climate variables, and such climate variables are fundamental. I'll tell you a little bit more about. I heard in the introduction Dagmar mentioning the importance and the relevance to tackle and support the COP agreements, in particular the COP21 agreements, and this is actually what we try to do with the collection of data, providing those data to the scientists who work on models over a long period of time, in general 30 years, to develop the models over the changes related to climate. Next slide, please. So here you see the different missions that we developed. Today we have 16 missions in operation, and we are developing 38 for the coming years. And we also are preparing the future generation with a number of preparatory phases studies. We have here with us today the Commission, and we do work together very closely since over 20 years over GMES, as Pignataro said, but Copernicus now. And there we developed the Sentinels, which is the sort of the space component of Copernicus. And we have started to launch the first Sentinel, Sentinel-1 in 2014. Today, we have 8 Sentinels up and running, all fully operational. The last one was Sentinel-6 microfralic, which was launched in November 2020, which looks at the sea level heights and the evolution over the sea levels. And with the Commission, the collaboration is extremely strong in the sense that the Commission manages 6 services. You'll probably hear more about it from Mauro, and we developed the satellite system that support the requirements by the European Union policies. And we actually developed those systems according to the requirements of the users and matching the satellite space technology to what is actually needed to be done. If it's forest monitoring, for example, you do that, for example, in areas like equatorial areas with radar instruments. If it's ice melting, the same, but you also need altimeters. So the various instruments which are on board these missions and which are developed are tailored to match the user requirements of the policies. On top of that, we have a series of satellites which are more scientific oriented, which are in general one-off and not in series like the family of the Sentinels, which are done in 1, 2, 3, 4 to grant data over a long period of time. And those scientific missions we call explorers, and they look at different aspects related to the environment. We have today one called SMOS, which looks, for example, at the ocean salinity. We have one looking at the soil moisture, the same mission. We have Aeolus, which looks at the wind profiles, Cryosat, which look at the thickness of the ice. So different scientific research missions that target various scientific activities related to the environment. And then last but not least, the collaboration with EUMETSAT, very relevant, very important. We started to launch the first Meteosat satellite in 1978, and today we work continuously with EUMETSAT in a partnership relation where ESA develops the future generations of the meteorological systems. Today we are developing MTG as next generation of METOP-SG, and they actually support the operational series of those satellites for which we do the procurement with industry and the procurement with the relevant European industry. Next slide. Here you see we actually support in ESA all what is considered the SDGs, so the societal development challenges, and we've been working very closely with the United Nations, not just with the Climate Convention. We are observers at COP. We mentioned now earlier COP26. We will be not only at the COP pre-forum in Milan in September, but at COP26 in Glasgow, and there ESA always presents through sides events, but also through a normal formal intervention in the high segment profile, what we do with our project, which is the climate change initiative. So supporting the climate variables of COP, which are the indication of how it's evolving the forest coverage, how the sea level rise is changing, how the ice is melting, and all those climate variables, there are about 50, over 50, which have been identified by UNFCCC. Half of those can be supported with space data coming from the satellites, and we have 21 which are currently being developed of those variables with ESA programs. But not only, what we do also in support of the collaboration we have with United Nations and also the United Nations priorities, you know, the SDGs, the Societal Development Challenges, were approved by General Assembly in 2015. We also work very much and very actively in the field of sustainable development, which means also working in the field of development, looking at natural resources management, for example, in Africa with dedicated projects, or working on supporting the Sendai context, which is the one related to disasters and natural disasters. Next slide. Yeah, I'm just mentioned Sendai, and of course, all these satellites, the scientific, the meteorological, and the Copernicus even more, they support the Green Deal. So today it's a priority for Europe, and Green Deal is really what we are supporting. You see here the 21 climate variables I was mentioning. These are integrating data from different sources. They involve a lot of academic scientific institutions in Europe. They involve also processing of very, very big numbers of data sets, high volumes of data. That's a challenge today for all of us. And I think it's something that can also be very beneficial to a sector like the one we are today with, in terms of also checking the evolution of the state of the atmosphere, looking at the greenhouse gases evolution. And we have specific dedicated tools to do that. Next slide, please. Can we go to the, yeah. So Copernicus, will hear more from Mauro, but basically it's the ESA EU collaboration under the EU leadership. And with this program, we look at better managing the environment overall and looking at the effects of climate change, but also contributing to wider initiatives like the one on GEOS. And there we have a policy which is a full, open and free data policy. And this data policy implies the fact that all scientists, industry who wants to do value-added activities, and all actors can actually benefit from the access to the data and use those for supporting their activities. Next slide, please. Here you see where we are heading. Copernicus today, as I said, has already 8 satellites operating, providing big volumes of data, 250 terabytes per day, but we are looking at the next steps. So what to do next? And this 6 new missions were actually approved in 2019 at the ESA Ministerial Conference in Sevilla, and they match additional requirements from the EU policies. And we have, for example, a dedicated mission looking at CO2, and this is going to look at CO2 of anthropogenic origin, so also to look at the stock take and support the stock take process in the context of the COP21 arrangements of Paris. We also have dedicated missions which on board have a L-band radar to look at vegetation, and also an hyperspectral imaging mission to support the agriculture policy, and of course other missions looking at the effects of climate change, for example, one devoted to polar ice snow topography, and one on temperature, land surface temperature emissions. So you see, in the coming years, we have quite a lot ahead of us, not only the challenge to develop with the European industry this mission, to grant that users will actually use the data, and that these will be also making, best economic return for those who want to actually do business with this data, and for the scientists who want to use this data in the future. And also granting from ESA the fact that these data of Copernicus, which are really valuable, are integrated with data from other sources, either new space sources, private initiative, but also other scientific missions like the Explorer ones I just mentioned. Next one, please. Here you have an example of very, very strong collaboration we have with the Commission. In fact, when the COVID crisis started, we decided in very few weeks, and we implemented with the support of over 30 industries in Europe, a dashboard, which is actually a web interface where you find a lot of indicators coming from satellites, mainly Copernicus source, but also other sources, looking at economic and agriculture ones, and over 200 sites in Europe. And what we did, we started to discuss with the Commission what was relevant for the citizens. We monitored all the lockdown period of prices, and not only the improvement of the air qualities in the city, but also planes stuck on airports or ports where there was less traffic, and things like a delay in harvesting strawberries, for example, in Spain, due to the fact that the people were stuck at home and there was lockdown. So very interesting development, which involved not only the use of the data for the citizens, I would say, because these are beneficial to everybody, but also involving an industrial development. Next slide, I think we have the example, which is quite striking, which I think most of you know, and it's relevant for this context because we're talking methane today, we are talking greenhouse gases. And this is an image, actually it's an animation comparing a monthly average of March, April 2019, so 1 year before the COVID crisis, and March, April 2020, where you see data integrated from a satellite of Copernicus called Sentinel-5P. It's a precursor satellite, as you can understand from the P, which has an instrument built by the Dutch called Propomi on board. It has a very wide resolution. It goes every day over the same area of the world, and has monitored over this average period in 1 year confrontation a reduction in NO2 concentrations of about 50% over the main cities in Europe. You see here Milan, Rome, Paris, Madrid, but this was looked at also all over the world. And it's interesting because this satellite looks at various elements component of greenhouse gases. So it looks at NO2, and this is what you see here is NO2, but it looks also at methane and other environmental parameters, which are very relevant to be monitored, and we will continue with future satellites to look at. Next one. Here you have a land cover example. So we are talking environment and what satellite can do. It's basically an animation of the evolution of the rainforest in Brazil from 1989 to basically 2019, integrating data from various sources from Landsat US, but and the evolution of the forest and the actual deforestation that has happened in this period. So it's just an example of how space can support environmental topics. And next one. I don't see the next slide coming, but maybe it's the animation which is low. So here you have a recent example. So the iceberg A74 that was measured through satellites in 1.5 of what the big Paris area is. It gives you the idea of over 1,000 kilometers that was cut off and monitored through Sentinel-1 in particular, which is our radar satellite that we have with the Commission. And it's quite a striking example of what's happening in areas which are quite remote, inaccessible, like Arctic or Antarctic regions. Next one. And here you have a scientific satellite, Aeolus. I mentioned that, but it's a scientific satellite which took quite some time to develop, by the way, because it has a LiDAR instrument on board, very advanced technological development and very challenging. It looks at wind profiles, but these data from this mission are being used daily operationally by ECMWF, the European Center for Medium Weather Forecast. For example, they include those data to do hurricane prediction in a very operational mode into their medium long-term perspectives. And more recently, they've been even integrated by the Indian Met Office since a couple of months. And here you see the monsoon to look and monitor at the monsoon activities over the Indian region. So a satellite that was born scientific, that's becoming very operational and very, very useful for clear uses, operational uses like ECMWF. And here you have another example of Aeolus and the operational impact in terms of prediction of hurricanes. We can go to the next one. I think I have almost finished my time here. So the ice sheet and sea level data. I told you we launched in November last year Sentinel-6 Michael Freilich. We have been integrating, and the data and the products from the satellites are just being validated and confirmed as very useful just a few days ago, but not still fully into the operational mode. It will be another few months to get into that. And we integrate data from Sentinel-6. It's a radar altimetry mission that basically we integrate those with data from previous missions, either JSON or national French mission, Topex Poseidon. So we have over a long period of time data over the evolution of the ice, but also over sea level. And sea level is one of the things that was mentioned in the beginning by, I think, Dagmar or Hilarias, and it's really relevant to see the evolution of the sea level. We have a trend which is quite dramatic there of millimeters per year, but over a century, we're talking about centimeters, and we're talking of big impact potentially on small islands, on also coastal areas. Italy, for example, is a country where we have over 700 kilometers coastal area, so potentially impact in many regions of the world. Bangladesh, we're working using data from those satellites on sea level rise, also with the World Bank. And of course, we look at ice melting ice, the melting ice impacts, in fact, on the sea level rise, because half of the sea level rise is determined by the rise of temperature, and the other half it's estimated by scientists to be determined by the melting of the ice, which is actually impacting on the level of the oceans. We go to the next one, maybe. And here again, you see some animation related to Sentinel-6. And as I said, integrating data from previous missions, Topic Poseidon, JSON, and we all work together. I must say, in the field of environment and climate, the collaboration is super strong. The relevance of the environmental climate change topic, it's the need to share data, to do collaboration. And ESA certainly is a good example with 22 member countries already, but we work worldwide with partner agencies, with the Commission, with others in Europe, and we need to actually put in common this relevant wealth, which are the data from our satellites. And you see here the trend I was telling you about, sea level rise trend. We are actually going from a 3.2 millimeter per year to a trend which is now estimated to 4.8 millimeter per year. And this is quite dramatic in terms of evolution. Next one, please.